In this video, I introduce FaF and FORES 3D detection and motion prediction using a single CNN. FaF and FORES is an end-to-end convolutional neural network, which performs a 3D vehicle detection and a motion prediction using a temporal sequence of 3D sensor data as input. For a given LiDAR point cloud, we partition this LiDAR point cloud into voxels to get a 3D broad eye view. Here we handle each layer as a channel. For the computational efficiency, we use the indicator to indicate if a voxel is non-empty. To predict the future trajectory for each detected vehicle, we need to use a sequence of 3D broad eye views. For example, we have n plus sweeps. So we put n plus 1 3D broad eye views together to get a 4D tensor. We use this 4D tensor as an input to the CNN network. CNN network uses to extract this feature maps from the input 3D broad eye views. And then now we use two output branches. One is a classifier to detect the vehicle, and another one is a regressor to predict the future trajectory for each detected vehicle. We use VGG16 as a CNN network. This VGG require input is 3D feature maps. So to do so, we use two kinds of fusion preprocessing technique. First one is early fusion. And so we put each 3D broad eye view in a channel direction. And then now we use a one by one convolutional layer to extract the features. And then we put this 3D features as an input to the VGG16 neural network. And then we use this output as an input for the two output branches to detect the vehicle and predict the future trajectory. Another way is the late fusion. Late fusion is gradually reduce the 4D tensor to 3D feature maps. First, based on each 3D broad eye view, we use a 2D convolution layer to extract the features from this 3D broad eye view. And then now we put a pair of the feature maps to use a 3D convolutional layer to extract their features. And step by step, finally, we get 3D feature maps and use these 3D feature maps as an input to the VGG16 neural network and get these feature maps as an input to the two output branches to detect the vehicle and to predict the future trajectory for the detected vehicle. Suppose we got feature maps from VGG16 here, and then we define 6 bounding boxes. One is based on 5 meters square. And then this 1 to 2, this 1 to 6, this 6 to 1, this 2 to 1, and this 8 meters square. And we put these 6 bounding boxes on these feature maps. And then now we use these two output branches, one branch to detect the bounding box is positive or negative. If IOU is larger than 0.4, then we say this bounding box is positive. And then for this positive box, the regressor to predict his location, dimension, and heading angle. To train the FaF and FORES model, we use a loss function that includes two terms. One is this binary cross entropy for classification. One is this weighted smooth error 1 for regression. This is because we selected this smooth error 1. It's good for outliers. For the binary cross entropy, this one is a class label, and this one is a predicted probability. So we use, based on this loss function, we use gradient descent method through a backpropagation to train the model. After we train the model can predict the future trajectory for each detected vehicle from the LiDAR point cloud input. For more details, please check with this reference. Thank you. Bye.